Hello everyone, welcome to my channel and welcome to another video on integration. In this video I have two integrals that I would like us to look at. The first one is this one here. We are to integrate dx all over x minus x to the power 2/3. Now the approach is looking at this term here, x to the power 2/3. We have to rewrite this expression and come up with something that will allow us to use u substitution as follows. Taking us to page number 1 here. Page 1, we are dealing with the first integral. It's the integral of dx all over x minus x to the power 2/3, like that. We're going to rewrite this term here as follows. So this will be the integral of dx all over x minus, watch this, I'm going to write this as cube root of x, and then I'm going to square the whole of that. Looking at the laws of exponents, you should see that that's exactly how you represent that. At this point, it allows me to say, because we have cube root there, we're going to say u cubed be equal to x. Two equations we must obtain from this one. The first one is to determine the value of u in terms of x. So take cube root on both sides. We're going to get u is equal to cube root of x, like so. That's the first equation. The second one is to differentiate u with respect to x. Because we have u cubed here, we have to use chain rule, differentiating that implicitly, of course. So basically, I'm saying we're going to say d with respect to x, in other words, derivative with respect to x of u to the power 3. This must be equal to derivative with respect to x of x. Now, on the left-hand side, remember we have to use chain rule. So it's going to be 3 u to the power 2, power rule there, and then we're going to say du dx. This will be equal to 1. Derivative of x with respect to x is 1. Multiply by dx both sides. You'll agree with me that what we get is 3u squared du, and that will be equal to dx. Fantastic. So now we have all the terms taken care of. Now if you look at in the place of dx, I'm going to have 3u squared du. And in this place of x here, I'm going to put u cubed. And there, obviously, I'm going to put u cubed also, because wherever there is x, I must put this expression here, u cubed. Right, so taking us to page number 2. So what we have is that integral now changes as follows. This integral changes as follows. Remember, I said where there is dx, I'm going to put 3u squared du. So I have the integral of 3u squared du. The numerator is taken care of. Dx equals 3u squared du. And then here I'm going to have u cubed in the place of x all over u cubed minus this part here. It has to be cube root of u cubed or squared. So cube root of u cubed, and we have to square the whole of that expression like that. So that is how you progress or proceed. Now let's simplify what we get here. So this is equal to the integral of 3u squared du all over, this is u cubed minus, notice cube root of u cubed is u, and we have to say squared. Going further, this is the integral of 3u squared du all over, now u cubed minus u squared. And in the denominator, you can see the common factor is u squared there. I have to factorize, and 3 is a constant, so I'm taking it out. So this is 3, the integral of u squared, and I'm going to say all over u squared. Factorizing this, it's u minus 1, and I'm going to multiply by du over there like that. Now you can see that this cancels that. So what I have 3, the integral of 1, obviously you have 1 there, all over u minus 1, and then du. You'll agree with me from the previous videos that you've watched, hopefully. If you haven't, please look back, check integrals that I've worked on so far. You'll agree with me that this is actually 3 natural log of u minus 1. You can also use u substitution here, but then we're saying plus c because this is an indefinite integral. Now we must, I'm saying the integral of 1 over u minus 1 du, this one here, you can actually prove that this is the case by using u substitution or t substitution, because we already have u here. You can say t substitution. Let me just show you immediately how that is done. So we are saying the integral of 1 over u minus 1 du. So I'm saying if you let t be equal to u minus 1, it means dt will be equal to du. Remember, 1 is a constant, derivative of a constant is 0. That integral, therefore, is transformed as follows. 1 over t, in a place of this one, I put t, remember here, and in a place of du, I put dt. dt, you agree with me, this is just natural log of t. But what is t? T is u minus 1. So this will be natural log of u minus 1. This is how I obtain this part here. But remember, we have to go back to our original variable. Our original variable is not u, is x. And what is the relationship between u and x? Here it is. It's the cube root of x that gives us u. So I must remove u and replace it with cube root of x, taking us to the last page, page 3. Our final solution is that is equal to, let me move this one down. Our final solution is this integral here. We bring this properly. This integral that you see, the solution there can be represented as 3 natural log of the cube root of x minus 1, and we have to say that the absolute value of that plus c. So this is the final solution to our first integral, which it basically is this one here. Where is our first integral? It must be here. Here is our first integral. We had to work on that expression there to obtain that one as our final solution. 3 natural log of cube root of x minus 1, absolute value of that plus c. Right, so that's the first integral. Let's look at the second integral quickly. I'm going to move to page 4. I don't want to continue on the same page. Page 4. Our second integral in this video is this one here. We are to evaluate or integrate square root of x all over 1 plus 4th root of x dx. Now, how do we approach this? Well, look at the 4th root of x. We can rewrite this expression here, and that will allow us to use u substitution. So these are examples, like I've said in the previous videos, of higher order u substitution. So integral number 2, we are saying it's the integral of square root of x all over 1 plus 4th root of x dx. I want to remind you something here. I think I must use a separate page. Use a separate page here. What is the meaning of this term here, 4th root of x? Well, you agree with me that this is actually x to the power 1 over 4. Because there's 1 here, which is the power, and to get rid of the root sign, we take this number, divide into the power, like that. But what does this mean? This means x power half to the power half, because half times half is a quarter. And what does this mean? This means square root of x. Remember, this part here is square root of x, and we must take square root of that. That's exactly what it means. All right, so I'm going to rewrite this integral as follows. The integral of square root of x all over 1 plus square root of x, like so, dx. Looking at square root there allows us to say, okay, so we're going to say now, let u to the power 4 be equal to x. Why power 4? Because we're taking square root twice. That's the meaning of 4th root. And so from here we can obtain 3 equations. The first one is to determine the value of u in terms of x, and we're going to take the positive 4th root on both sides. So it will be u is equal to 4th root of x. The second equation is going to be, remember, we have square root of x in the numerator. So we need square root of x from this equation here. You'll agree with me that it will be u to the power 2 is equal to square root of x. We're taking the positive square root on both sides to get that. And so we're moving on now to our third equation, which basically is differentiating implicitly on both sides, or using chain rule. So we're basically saying d with respect to x, derivative with respect to x of u to the power 4, this should be equal to derivative with respect to x of x on the right hand side. And how do we do it here? Chain rule. 4, differentiate the u power 4 first, so that will be 4. I'm going to get rid of this one here. It's 4 u to the power 3. Remember, applying power rule. 4 u to the power 3, and then we have du dx. What do we have on the right hand side? 1. Multiply both sides by dx. What do you get? You're going to get 4 u cubed du. The answer is equal to dx. 3 equations there. So that means this part is taken care of, that part is taken care of, and that part is taken care of also. So let's look at how we transform that integral then. Taking us to page 5. And so this integral here, in the place of square root of x, I'm going to put u squared. So we have the integral of u squared all over. I have 1 plus 4th root of x, which is 1 plus 4th root of u power 4. Remember, x is u power 4. There it is. And what do we have in the place of dx? Well, we have 4u cubed du. 4u cubed du. Perfect. Now we can go ahead and perform the integration there as follows. 4 is a constant. I'm going to take it out. So that's 4 times the integral of this term and that term will give me u to the power 5 all over. This part here is 1. 4th root of u power 4, the positive root there, is actually u. And then we have du. At this point, I'm going to rewrite the denominator as follows. So this is 4 times the integral of u power 5 all over u plus 1, like so, du. Now, this allows me to use what we call long division as follows, because I see the u power 5 there and we have u plus 1. So using long division, we have u plus 1 dividing into u power 5. So we take u into u power 5, it's actually u power 4. Multiply this by the whole term here. Multiply u power 4 by the whole expression. So it will be u power 5 plus u power 4. And then we subtract. These will cancel. That will be minus now. U power 4, like that. And then I'm going to repeat the process. U into minus u power 4 is minus u cubed. And then I'm going to take that multiplied by the whole expression. It will be minus u power 4 times minus u cubed. Remember, minus here, minus u power 3 times u is minus u power 4. Minus u power 3 times 1 is minus u power 3. And then subtract. This becomes positive u power 3 now. And then I'm going to repeat the process. So u into that is actually positive now, u squared. Multiply the whole expression. I'm going to have u cubed plus u squared, like so. I subtract again. Remember, these cancel, and I'm going to, of course, these two cancel, and I'm having the positive one there. And now here, these two cancel, and I'm going to have minus u squared. And what do I do next? Repeat the process. U into, I'm going to say u into minus u squared. The answer is minus u. Multiply by u, it will be minus u squared. Multiply by 1, it will be minus u. Let's subtract. The answer is u. And I'll proceed again. U into u, the answer is positive 1. Positive 1 times u plus 1. Let me bring this one up this side. It will be u. Down here, I'm going to have u plus 1. And I have to subtract this. So I took this one up there. Subtracting, the u's cancel, I have minus 1. So what are we saying now? Taking us to page 6. So we are saying now that this expression here can be written as that term, that term, that term, that term, and 1 plus 1. And then, remember, there is a remainder here, minus 1 all over that. So basically, we are saying 4 times the integral of u power 5 all over u plus 1 du. This is the same as 4 times the integral of Watch how I'm going to write this. It's u power 4 minus u cubed plus u squared minus u plus 1 minus 1 all over u plus 1 du. This is what we're getting here after long division. That's what we're getting here after long division. Remember, our remainder is minus 1. When you divide that into that, remainder is minus 1. So we have to have remainder all over the divisor. Remember the remainder over divisor there. Now we can perform integration of each term. So having a 4 outside, I'm just gonna do the integration of each term straight away. So keep 4 outside. This one here, it's gonna be power 5 over 5. And then we have minus u power 4 over 4. And then we have plus u power 3 over 3. Then minus u squared over 2. And then 1 is gonna be u. And then this one here, you'll agree with me that the integral of 1 over u plus 1 is just minus. Here we have minus, obviously, natural log of u plus 1, like so. And then I have to say plus c, because the integral is indefinite. Distribute the 4. You'll agree with me the answer is going to be 4 over 5, u power 5, minus u power 4, plus u over 3. 4 over 3, u power 3. And then here it will be minus 2u squared plus 4u minus 4, natural log of u plus 1. And then I have to say plus c. There, like that. Now let's get rid of u. Go back to our original variable. What is our original variable? Taking us to this page here. If you check, our original variable is x, and the relationship between u and x is that u equals the 4th root of x. Right, so where there's u, I'm going to put 4th root of x. Remember something here. This here is exactly the same as x power 1 over 4. Like I said over here, there, x power 1 over 4. Right, so I'm going to put x power 1 over 4 where there's u. So this is going to be 4 over 5. I have x power 1 over 4, but this has to be raised to the power 5. And then minus, again, x power 1 over 4 has to be raised to the power 4. There. And then plus 4 over 3, x power 1 over 4 has to be raised to the power 3. Minus 2, x power 1 over 4 has to be raised to power 2. And I'm here now plus 4 times x power 1 over 4. And then minus 4, natural log of here x power 1 over 4. Remember, that can never be negative, so I'm going to use round brackets, x power 1 over 4, and then I have to say plus 1, like so, then plus c. Simplifying this, coming up with our final solution. Our final solution is going to be 4 over 5, and then I have x power 5 over 4, and then I have minus, this part here is just x. You can see the 4's cancel there, plus this term here is going to be 4 over 3 x power 3/4, and then that part is going to be minus 2 x power half, which is just square root of x. And then I'm here plus 4, and I have x power 1 over 4, which is just 4th root of x. And then I have minus 4 times natural log of, I can keep this one the way it is, or I can write it as 4th root of x, like that, plus 1, and then I'm going to have to say plus c. So that is our final solution to integral number 2. I was requested to bring up more questions on u-substitution, and many more questions are coming your way. Here we just had 2 integrals. Our second integral was this one here. Provide your comments. Let's see what you say. Let's hear what you say about these 2 integrals, alternative approaches, and so on. We really appreciate your feedback. All right, I'll see you in the next one.